All right, so we have here is our original problem in 11a from our classwork, and we are going to be solving this compound linear inequality in one variable. Now, when we have a compound linear inequality, remember we have three distinct parts of an equation. We're working from the middle to both the left and to the right side, solving two equations or inequalities simultaneously. So first of all, we want to get this 3 away from the variable term. So we're going to add a negative 3 to all three parts. And so now we'll have a negative 2.5 over here, and then we'll have less than or equal to, and we'll have a negative 5/2 x here in the middle, and then we'll have less than 13 minus 3, which is 10. Now next, we're going to get rid of the numeric coefficient. In order to get rid of the numeric coefficient, we're going to multiply by the reciprocal here, negative 2/5. So negative 2/5 here, and also over here on the right hand side. Remember, there are three parts to these equations, and all three parts have to get worked on. Now, because we just multiplied by a negative, right here, we have to flip the senses of the inequality. So here we have a greater than or equal to now, and here we have a greater than. And that has to get done when you multiply or divide by a negative number in an inequality. All right, so we'll go ahead and we'll finish this up. So when we multiply 2.5, we have to have mixed numbers, or an improper fraction, not the mixed number. So 2 times 2 plus 1, so we have 5/2, and 5/2 times 2/5, anything times its reciprocal, remember, is equal to 1. So we're multiplying a negative times a negative, get a positive 1, and then a negative times a positive, we get a negative, and 5 will go into 10 2 times, and 2 times 2, which is equal to 4. Now we're going to take our pancake flipper, flip this thing over, we get our negative 4 over on this side, our positive 1 over there, our x stays in the middle. The inequality here points toward the x with the 1, and the inequality here points toward the negative 4, so we point it toward the negative 4. Now we have that written out, so we will take our number line, and then we will 1, 2, 3, 4, and 5, and put our numbers on our number line, 1, 2, 3, 4, and 5, and then we will mark our endpoints, and our endpoint of negative 4 right over here is not included, so it gets a scoopy loopy, and then over here at positive 1 we get a bracket, chomper down on it, and then we have a line in between. And there's our graph, and the interval notation, remember, takes a snapshot of what we see on our number line, so negative 4 on the very left hand side up to positive 1 on the right hand side. Negative 4 is not included, so it has a parenthesis, and 1 is included, so it has a bracket, and that's our final solution. Now moving on to part B. In part B, we have a linear inequality, which is going to get solved just like a linear equation. So we're going to do distributive property, 2 times x plus 2 times 4, which is equal to 8, plus 3x, and minus 11 is greater than 3x minus 9. 3x minus 9. And now we need to combine the like terms here and here, and here and here. So 2 and 3, which makes 5x, and then 8 and negative 11, which makes it minus 3. And then that's greater than 3x minus 9. Now we need to get the x's together, so add an opposite of 3x here, add an opposite here. Remember, nothing happens when we're adding negative numbers. It's only when we multiply or divide. So 5 minus 3, which is 2x, and then minus 3 is greater than negative 9, and then we're going to move the 3 over here, add 3 and 3, so we get 2x here is greater than negative 9 plus 3 is a negative 6, and now we multiply by the reciprocal of 2, which looks like division by 2 because it is, and finally we get x is greater than a negative 3. Remember that this is not dividing by a negative. It's a negative number already. We just divided by a positive number, so nothing happened to the inequality. And now we need to plot that on my number line. So we have our numbers here. Get this all filled in, labeled up to 5 and negative 5 on each side, and then we can put the entire solution on the number line. and we have our endpoint, which is -3. It's right here. It is not included because we have this in standard form, a variable on the left and the number on the right. It tells us exactly what our solution looks like. It starts there and it pushes on to the right. And now interval notation. On the left we have a snapshot of -3, which isn't included, so it's got a parenthesis around it. It goes off to positive infinity, which can never be touched because it is an idea and not a number. Moving on to our example number 12. Number 12, we have a linear inequality in two variables. Linear inequality in two variables is very different than a linear inequality in one variable. Linear inequality in two variables is going to be solved just like a linear equation. We're going to put it in slope-intercept form. So y is greater than positive 3x minus 4. And so we're going to be taking the y-intercept, -4, and we're going to graph it, and then we're going to use the slope, m is equal to 3, to put a boundary line here on our solution. Now I'm going to go back and I'm going to find one of my really kind of poor graphs here, but at least it's a graph of some sort. And I'm going to put in my coordinate system here, and here, and here, and here. And as always, you have to use your imagination and be lenient with me when I do it this way. And then we're going to go ahead and we're going to put in our boundary line. So we're going to put in a -4, 1, 2, 3, 4. That's our y-intercept right there. And then we're going to use our slope to find a couple more points. So slope is rise 1, 2, 3, run 1. And we'll label that x equals 1, y equals -1. I'll run out of places down here, so I'm going to go up again. Up 1, 2, 3, and over 1 again. And I'll label that. So x is equal to positive 2 and positive 2. And then I'm going to go up another point up here. 1, 2, 3, and over 1. And I'm not going to actually label that one. It's just going to help me make my boundary line because you know how difficult it is. Now, because this is a strict inequality, my boundary line is a dotted line. So I make sure that this is dotted because nothing on this line actually solves that inequality. And now I have my region into two regions, so one above it and one below it. So I have an above checkpoint and I have a below checkpoint. And above checkpoint, I'm going to be using 0, 0. So I'm going to have a checkpoint here above and a checkpoint here, and that's going to be below. And my below one, I can use anything below the line. I like to use something on an axis so it's easier checking. I always go back to an original equation, not to my slope-intercept form. So I'm going to use this over here. So y is equal to 0 minus 3 times my y, which is 0, and that is greater than -4 is what I'm saying. And 0 is greater than -4 is indeed a true statement. And then from over here, I have x as 0 and y as -5. So I have -5 minus 3 times x, which is 0, and that's greater than -4. Now, again, I'm asking if this is true. So this says -5 is greater than -4. And again, that is a false statement. And so what I see is where it's true is where I'm going to shade. So this is true, and therefore I'm going to shade. And the shading region is the region above here. So I'm shading the region above this line. And before I finish it up, I want to make sure I put the equation on there. So I'm going to put y minus 3x is greater than -4. Oops, and I don't think I'm going to be able to finish it up there because I keep touching the eraser. That doesn't work. So -4. And at any rate, there we are, and that's the solution. All right, our last problem down here, we have find the solution to this system. Well, the solution to a system of linear equations in two variables is simply the intersection of these lines. So we see that x is 2 and y is 2. So the solution to that system of two equations and two unknowns is positive 2 and negative 2. So on number 13, the solution is the intersection of the lines, which is at 2, 2. So intersection of lines. Just like that. And that is our solution. Okay, and that'll wrap up this video. I'll do the last few in another video.